right, 3.4 B as in boy. So let's go ahead and continue on. We're in example 2. And they said find the slope of a line that goes through -2. Oh, my ink stopped working. -2, 1, and 5, -4. All right, so they gave you those 2 points. Now you can graph those if you want, if it helps. We'll graph it later, but right now let's try to do this using this formula. Okay. So let's just plug those numbers. There's a place for 1, 2, 3, 4 numbers, and we have 4 numbers listed there. So let's go ahead and do this. So y2, let's make y2 -4 this time, and y1 the number 1, so we use those two, over x2 is 5 minus x1 is -2. Okay, so -4 minus 1 is -5 over 5 minus -2, which is the same as adding, and you get -5 over 7 for your answer. And you're done, because it gave you your 2 bits of information. It told you how steep the line was, and it also told you not only how steep it was, but what it does. It goes downhill from left to right because of that negative, which means, let's get the graph out here again. Let me see if I can find it real quick. Got it hidden away in my photos. Okay, so there's -5, 7. So -5 and up. Oops, I'm sorry. What am I doing here? Let's graph the 2 points. -2, 1, and 5, -4. So yes, it's doing what I thought. It's going downhill from left to right. That's what that negative tells me. And 5 over 7 is how steep it is. All right, so let's jump to example 3. And example 3, what they did with that is kind of going backwards. They're giving me the graph, and they're putting the line on the graph, and they're saying find the slope given that bit of information there. So they're telling me I've got a point at 4, -1, and another point at -4, -4. So I'm just redrawing this here. Oh, that's a terrible line, isn't it? I wish I had a line thing on my iPad, but I have to draw my own. All right, so it's asking us to find the slope. Well, we know that our slope is rise over run, y over x, the difference between y and x. So what I'm going to do is I'm going to draw a little triangle here. Okay. And I can tell what my y is, my rise, based on this number right here. 1, 2, 3. Over my run, which is the distance between here. 1, 2, 3, 4, 5, 6, 7, 8. And there's my slope. I'm done. Okay? And it goes uphill from left to right. That's why it's positive. And the 3/8, it isn't real steep because it's a little less than a half. But that's pretty much it as far as looking at a drawing. Just find out how far it is between the bottom of one point to the next point. So here to here, that's your y. That number goes there. And the distance between here and here, and that goes there. Okay? And that's all you're doing with that. All right, so graphing with slope, which is the next section on this lesson. It says graph the line with a slope -3/2. So this time they're giving you the slope and they're asking you to graph it. And that's what they give you. And it also says that it's going through point 1, 1. They have to tell you a little more than just the slope. Because this slope here, and these all have the same slope, right? They're just on different points of the graph. This point here gives you an idea of where on the graph that line is at. And I'll show you what I mean here. It says 0.11. Let's graph that. So I know that that slope that they're asking me to draw goes through that point. Well, look what I've got. I've got all kinds of slopes that go through that point. That's what this does, is it tells me which line goes through that point. I can't erase and talk at the same time. 1, 1 goes through that point. All right, I know that the top number is represented by the y and the bottom number is represented by the x, right? Change in y over the change in x. Okay, so I always start with the 1, 1, and then I look at the negative 3, 2. The negative 3 is the y, the 2 is the x. So I start here, and I do what this says. This says that if I start here, I go negative 3 up or down because of the y, and because it's negative, I go down. So I start here, and I go down 3. So 1, 2, 3. So I'm down there. Then it says go over 2. Well, it's a positive 2, so I know I go to the right 2, and I end up there. So what this does is this tells me what point I start at, and this negative 3 over 2 tells me where another point on the line is. So if it's another point on the line, I can draw a line that connects those 2 points together. And there's my graph of the line that goes through 1, 1 and has that slope, because I do this. This is my negative 3, and this is my 2. Okay? Now what if instead of negative 3 over 2, it was 3 over negative 2? It wouldn't change things. Things would be the exact same. Let's do that. Let's try that. So we're still starting at 1, 1. And this says go up 3 because that's positive. So I'm going to go up 3, 1, 2, 3. And then it says go over negative 2. So I'm going to go over 1, 2 this way and end up there. Okay? So I end up at a different point, but I end up at a point that's still on the line. So even if I didn't have this point here, when I draw this line through this point and through this point, I still get the exact same line. So again, it doesn't matter if the negative's down here or up here. It can't be in both places. If you're going to put if there's a negative there, it can either be on the top number or the bottom one. You will get the exact same line when you draw it. So no problem there. All right, let's look at example 5. Example 5, and I'm talking pretty fast today. Just trying to make these videos as short as I can. All right, so find the slope of the line containing 3, negative 1, and 3, 4. All right, so we're finding the slope, and we are going to do it the exact same way we've done it before. Remember, it was y2 minus y1 over x2 minus x1. You like my 80s music I'm playing? Okay, so we're going to take y2, 4, minus y1, which is negative 1. Okay, so here's the one of the y's I took, here's the other y I took. And we're going to put that over x2, which is this 3, because I use this 4 as my y2, so I have to use this 3 as my x2, minus this x. So that gives me 4 plus 1 is 5 over 3 minus 3 is 0. Whenever you have 0 on the bottom, a slope does not exist. You have no slope. You do not have a slope of 0. You have a slope that does not exist. And if you've ever skied, you know that a slope that is like this does not exist. That is not a slope. That's straight down. Okay? A slope has some angle to it. There is no angle there, and you will die. So if you don't have a slope, you have a cliff. So a vertical line means no slope, and you will only get a vertical line if that bottom number, if the two x's are the exact same number, you will get a slope that does not exist. All right, now let me show you a slope of 0. A slope of 0 is, let's see, is if the y's are the same. So let's say I had 0.32 and 0.62. Now if I graph those, I get 3,2 and I get 6,2. And if I draw the lines together, I have a slope of 0. If you're standing there on the bunny hill and you have no slope, you ain't going nowhere. So we end up with y2 minus y1 over x2 minus x1, which is going to be 2 minus 2 over 6 minus 3, which equals 0 over 3. So notice I get a 0 on the top. So when you get a 0 on the top, your slope is 0. When you get a 0 on the bottom, your slope does not exist. Okay? Very important to remember the difference between those two. That will save your tail when you're doing some of these problems. Okay, so let's look at perpendicular and parallel lines real quick. Parallel lines are lines that have the exact same slope. Okay, they never cross. They are non-vertical lines. Vertical lines, remember, have no slope at all. So they're non-vertical lines that are parallel, and they are meaning they have the same slope. They never cross. A perpendicular slope are two lines that cross at 90-degree angles. Maybe you've got a line like this and a line like this, but the line here is 90 degrees. I put a little box there because that shows that it's a 90-degree angle. That's the symbol there. Okay, so I said if they're parallel, their slopes are the same. Okay, if they're perpendicular, and there's a symbol for parallel, it's two straight lines. Perpendicular, the symbol looks like that. So if they're parallel, the slopes are the same. If they're perpendicular, the slopes are negative reciprocals is the right word. But let's say that you have a slope of 2/3. The perpendicular would be whatever this is, make it its opposite in sign, and flip the number over. That would be the slope of the perpendicular. Let me try another one. If I had a slope of 3, I'd write it as 3 over 1. The perpendicular would be 1 over 3, and since this one's positive, this would be negative. If I had negative 2/3, the perpendicular would be flip it over and make it a positive because this is a negative. So if you're given an equation with slope and you want to find a quick and easy way to find the perpendicular, that's why you just take the slope, flip it upside down, and take the opposite sign. And we'll get to some of those and you'll see how all that works. But that's what the perpendicular is. So example 7 here, see if we can get done with this before I run out of time. Determine if the lines passing through the given pairs of points are parallel, perpendicular, or negative. So we've got -1, -5, sorry about that, 2, 1, and -2, 2, and, oops, these two are related. And so they're saying these two are going to make a line, and these two that I'm writing here now are going to make a line. Okay, because it said between these 2 points and these 2 points. So let's bring our slope back up, or our graph back up here and graph this. So -1, -5 is right here, and 2, 1 is here. Okay, and then -2, 2 is here, and 6, -2 is there. Are those perpendicular or parallel? Well, we're not going to tell just by looking at the picture, but it looks like they're going to be perpendicular. Mathematically, you can figure out if they're perpendicular or parallel because we can use our y2 minus y1 over x2 minus x1. So let's use that in this to find the slope. So we've got -5 minus 1 over -1 minus 2. And that equals -6 over -3, which equals positive 2 over 1. Okay, now let's look at this one over here. See what that slope is. 2 minus -2, y2 minus y1, -2 minus 6, x2 minus x1. So 2 plus 2 is 4. -2 minus 6 is -8. So that gives me a -1/2. Okay, now look at my two slopes. They're flipped upside down, and one is a positive and one is a negative. Therefore, they're perpendicular because the slopes are flipped over and the signs are opposite. If they were parallel, the slopes would be the exact same number with no changes. They'd either be -1/2, -1/2, or 2 and 2. Okay, one or the other. Neither means you just have two completely different numbers for the slope, like 1/2 and 3/8 or something. So we didn't run into that. So that's it for lesson 3.4.